He's still responsible for the homework though. He may just be having computer issues again. I know he had that one week. Okay, so a couple things. The language that I'm going to be using is called BASIC. It's one of the earliest programming languages, sort of the basis for several other more modern programming languages that you might actually use if you wanted to program on the computer. The reason why I'm using BASIC is because our graphing calculators actually run on BASIC. So that means if you've got a graphing calculator, we can program your calculator to do a bunch of different things. So I've got an example here that can convert temperatures from Fahrenheit to Celsius and back and forth. And we'll be looking at a way to program your calculator to do Euler's method a little bit later. So let me start out by showing you some basic commands. Okay, so first, if you want to start programming in your calculator, you can hit the program button and then go to new. I'm going to create a new program and we'll name it whatever we want. So in this case, let's do, Euler's. And we can start to program that. Okay, so once we're in our program, you'll see a colon here. So we are now writing our program, and the computer is just going to run through line by line by line all of our code that we write. So to write our code, we'll need some sort of an operations that'll tell it what it wants to do, and then we can give it arguments. So if I hit program, for instance, and scroll over to input output, I can scroll down to display. And then whenever I put in quotes afterwards, it will be displayed to the user. So this will be a message that comes up when we start writing our program. So for us, jump into our pseudocode here. Pseudocode is a way of planning out how you want to do your program. So in this case, I want to create a program that will allow us to do Euler's method. So it'll tell us what the expected y value will be and any expected number of steps. So that means the user is going to have to give us a couple variables. They're going to have to give us the starting x value. A starting y value, a step size, so that's your dx, and some number of steps. And then after we do that, I'm going to move over one step and print out what the next y value would be. And then just keep printing it out from that. Okay, so the first thing I'm going to do in my program is I'm going to display a message asking for some of this information. So I need a starting x value and a starting y value. So I'm going to display, go into quotes, so that's alpha quotes. If you want, you can hit the second alpha and that will lock you into the alphabet. So now if I keep typing, it'll do the letters in green. So I want to ask for a starting x value. So starting x. Okay, then I'm going to ask for the user to give me some input. So program input output input, and whatever they type, I'm going to store as the variable x. Okay, so input takes one argument. It's usually a letter. And it's going to store whatever number that the user types as that letter. So in this case, when we run the program, it's going to prompt starting x, and the user will have to type in the starting x value. Okay, I'm actually going to add to this, I think. So if you want to add a line, hit second insert and then enter. I'm actually going to clear our screen just in case the user already has some other stuff in the calculator. So that's programs, control, clear home. Okay, home is the name of the screen. That's everything that's being displayed right now in the calculator. So I'm going to clear the whole screen so that the top line will just say starting x. The program will stop and it'll wait for the user to type in a number. And whatever the user types will be stored as x. Okay, once the user types the number and hits enter, then the program will keep going. Okay, I'm going to do that again. Program input output display. So second alpha lock, and I'm going to ask for starting y. Starting, oops. Starting y. Okay, and then I'll do the same thing, ask the user to input a y value. So that's program input output input. I'm going to store this value as alpha y. Okay, so we have two variables now that we can use for our program, x and y. Okay, I'm going to add an extra line here. So this is second catalog. I'm going to turn functions off. So what that will allow me to do is to have different y values for the same x value in case that's happening with our function for the Euler's method. So now x and y are not being treated as functions. That allows me to use them in an equation instead. Okay, then I also need a step size. So program input display. I'm going to ask for a step size. And store whatever they type as h. Okay, so we've got three variables now. If I go back up, the user has given us x, y, and h. So we have a start point, and we have a step size. That's our change in x. Okay, so Euler's method, if I go back, takes our previous y value and adds our slope times our change in x, and then stores that as our next y value. Okay. All right. So next thing I need, I'm going to assume that we have an equation for the slope stored in y1. So that I'll be able to use that. And I'm going to ask for a number of steps. So display, I'm going to ask for a number of steps. I do need quotes for that, so I'm going to have to go back and add my first quote because I forgot. That second, insert a quotation mark. Okay, display number of steps, and I'm going to store whatever they say as n. Okay, so now I've got 4 variables that I've gotten from the user. So that's their step size, number of steps, x and y, starting x and y. And I'm assuming that their y1 is currently storing our equation for the slope. Okay, so I'm going to clear home again. So that just clears the screen of anything that's still on the screen. And I think I'm going to store this as a list this time. This is slightly different than what I might have written on your example sheet, but I'm going to clear all lists. So second memory, clear all lists. Okay. So let me go back to my pseudocode and explain what I'm doing next. What I'm going to do is I'm going to run through Euler's method and then keep adding 1 to the counter until my counter eventually reaches the number of steps that they told us. So if they said they wanted to take 4 steps, then I'm going to start my counter at 1. I'll do 1 step, add 1 to the counter. So my counter is 2, do it again, add 1 to the counter, counter's 3, do it again, add 1 to the counter, counter's 4, run through and stop. Okay, so that means every time that I go through this, I'll need to add 1 to the counter, calculate the new y value, calculate the new x value, print out the information, and then replace the previous y value with the new y value, replace the previous xy value with the new x value, and do our calculation again. Okay, I'm also going to check to see if the counter is equal to the number of steps. If it is, then we will end the program. If it's not, we'll come back around and do our calculation again. Okay, any questions on our pseudocode? Okay, so I'm going to call our counter I. So now I've got several different variables here. We've got our steps is listed as n, our change in x is currently h, our y is y, our x is x. And I'm going to create a new variable that I did not ask the user for, which is I, which is our counter. I is typically used as a counter. It just stands for iteration. You've seen it before when we've done our summations, where we started at 1 and then went to a number, n. So if I did this, the sum of I equals 1 of x to n, I would go 1 plus 2 plus 3 plus all the way until I got to n. Okay, so let's write it out. So the first thing I need is a counter. So I'm going to store 1 as our variable I. So now we've got a new variable I that's listed as 1. Okay, now this next line is going to start our loop. So I'm going to set a label here. so that I can jump back to this point if I need to repeat. So I'm going to go to Program, and I'm going to label this. Okay, so that's control label as label 1. Anytime I want to go back to that line, I can ask the program to go to label 1, and it'll come back to this line and keep going down again. Okay, now there are several different types of loops that we can use in programming. The 3 most common are if, for, and while. An if statement would be something like, if x is less than 3, then do this next block of code. You could also say else, which means if x is not less than 3, do something else. A for statement means you'll continue doing this loop until something is true. So you could say for x equals 1 until x equals 3. Do this loop. And then add 1 to x at the end of the loop. And it would keep going through the loop until x equals 3. I'm going to use what's called a while statement, which is similar. So I'll show you what I mean. So this is while our counter I is less than just be under numbers. I don't remember. There we go. Under test. While I is less than n plus 2, I'm going to store x as the first entry of list 1. So this is in list 1, entry number I, which is currently 1, will be stored as our starting x value. In list 2, I'm going to do the same thing for y. Whatever our y value is right now, I'm going to store as list 2. On that same line. So right now I is 1. So my first entry on list 1 is my x value. My first entry on list 2 is my y value. Okay, then I'm going to do Euler's method. So our y value plus, so that's my previous y value, plus my slope, which is currently stored under y1, times h. I'm going to throw parentheses in here just in case it doesn't do order of operations. I don't remember. Times h. So that's our previous y value plus our slope times our change in x is going to be stored as our new y value. So that will replace our y value. And then my new x will be x plus h. which I will store as our new x value. Okay, then I'm going to increase the counter by 1. So I plus 1 will be stored as our new I. Okay, then I'm going to jump back and repeat our while statement. So I want to go back to label 1 so that we can repeat. And we'll see if that works. Go to 1. Okay, so once again, what I'm trying to do from the top, I'm going to ask for a starting x value and grab their x value. I think I'm going to make this a little bit cleaner. I'm going to add one more line here where I clear our home for each of these. So I'll grab the starting x value from the user and then clear the screen. Ask for the starting y value, get it from the user, and then clear the screen again. Ask for a step size, then clear the screen. Oops, that's the same line. I want to go up here. Ask for the number of steps, clear the screen, clear all of my lists. Then we created a counter starting at 1 and a label, so it's a point that I can jump back to. So as long as our counter is less than n plus 2, I'm going to keep running through our Euler's method code that will store our x values in list 1 and y values in list 2. So the first time through I is 1, second time through I is 2, then 3, then 4, then 5, and it's going to keep going up. Okay, so let's try it out. In y1, I'm going to go ahead and type a slope. So let's say our slope is y plus x. We'll check really quick by doing this by hand. Okay, so our slope is y plus x. I'm going to say our starting y value is 2, our starting x value is 3, and our change in x is 1. I want to do 4 steps. Okay, with Euler's method, what would happen first? Okay, so my formula is... Okay, so my new y value, so that's y value when x is 4, should be equal to our previous y value, 2, plus our slope, 2 plus 3, times change in x, which is 1. Okay, so y4 then should be equal to 2 plus 5 is 7. Okay, then y5 would be equal to our previous y value, which is now 7, plus our slope, which would be 7 plus 5, right? Oh, 7 plus 4, our previous x value, times our change in x. So y5 should list as, this is 7 plus 11 is 18. Y6 would be 18 plus our previous y value, 18 plus our previous x value of 5 times our change in x. Y6 should list as, this is 41. We said we want to do 4 steps, right? So I think I've got one more. Y7. Okay, times our change in x, which is still 1. Okay, so that's 88. Okay, we'll see how well our calculator does. So hopefully, cross fingers, this will work. So my y value is y plus x, or our equation for the slope is y plus x. And we're going to run our program. So that's program execute Eulers. Okay, it's asking us for a starting x value. Our starting x value is at x equals 3. A starting y value. Our starting y value is at y equals 2. We have a step size of 1 and a number of steps of 4 steps. Okay, so if we did this right, when I go into the window for our lists, we should see all of our x and y values through Euler's method. You can see. So starting at x equals 3, y equals 2. At x equals 4, y is 7. X equals 5, y is 18. X equals 6, y is 41. And x equals 7, y is 88. So we've taken a process that we might have to do by hand and turned it into something that we can use the computer for instead to keep automating it for us. So now that I've proven that it works, I can break out of this and I'm going to run that one more time and see what would happen if I did this 100 times. That's something I don't want to do by hand. So starting x is 3, starting y is 2. Step size is 1, and I'm going to do 100 steps. Okay, so now if I go into our list window, scroll up, we can see that after 100 steps, we are at 9.5 times 10 to the 29th power, which is a huge number, but not something I would have wanted to do by hand, right? Okay, again, this is a pretty basic application of programming, and typically if you're going to use programming for pure math, you're not going to use this programming language, but just because we had the calculators available, I figured it's a good place to start. It's an easy language to pick up, I think.
Okay, well, yeah, that's true.
Alright, so I've got an example in our document, which goes over everything that we looked at in our program, which is where... here. So all of the commands that you would need in order to do everything that we did in our program. And then what I want you guys to do is this. I want you to take the compound interest formula from last class period, solve your formula for time, and then write a program that asks the user for a goal, principal, and interest rate, and display the time that it would take their investment to reach that goal. Then, as a stretch of that, once you've written that program, it would display your time in years with a decimal. But because most people don't think in terms of like 1.3 years, I would want you to change the program to display the number of years, months, and days that the investment would need to mature. Okay, so we'll give it a shot, and I'll take this up on, we'll say Wednesday of next week. That'll give you a chance to ask me any questions that you've got after trying it on Tuesday.
Oh, okay.
Okay. All right. Any questions on anything from today?
No.
All right. That was a lot at once, not a ton of interaction, and I apologize, but because everything's new, this is more of a lecture. So I'm going to stop recording. I'll post the video for later. And if you want to go back again, it's the intro to programming file. Shows you all of the steps in another example program, and how to create it step by step in the calculator, in case you want to follow along. Do you have a graphing calculator available?
Not yet, but I can download on my phone.
Okay. So I'll send those files again.